Hi, this is Erik with Technically Speaking at Source Allies. Today we're going to be talking about Kubernetes, except we're going to be talking about it the wrong way. So here we are, talking about Kubernetes again. I'm glad that you've joined me. You know, one of the common things that I hear when people talk about Kubernetes is that it's really confusing and has a steep barrier to entry. A lot of people are put off by that level of complexity and understandably don't really want to get involved with it. You know, if we go to the documentation site here, you know, there are some pretty good docs. We got a getting started section where they show you how to set up a learning environment, but it's pretty understandable that someone can get lost in terms like deployments, pods, containers, services, ingresses, load balancers, horizontal pod autoscalers, and all these sorts of things. So, you know, one of my coworkers, Ben Pratt, has this wonderful talk called The Foundations of Kubernetes, where he brings up a very amazing point that at its core, Kubernetes is just a plain old CRUD REST API. And I really latched onto this. So I was thinking, what if we used Kubernetes entirely incorrectly to demonstrate this? I think that HTTP REST APIs are incredibly common to encounter in a career as a developer. For me personally, my first task at my first job out of college was adding endpoints to an ASP.NET web API that was consumed by some JavaScript website somewhere. So I'm thinking today, let's see if we can write a plain old REST API for our own data using only Kubernetes libraries. No web frameworks, no fancy schmancy stuff. Just doing it from scratch, using only the stuff that Kubernetes has given us. So to do this specifically, we're going to utilize the Kubernetes Extensions API to have a cluster serve up our data over HTTP and then consume it from JavaScript. So one of the concepts of Kubernetes that we will be talking about in addition to the whole CRUD REST API stuff is that Kubernetes has concept of resources. So this can be loosely related to, when you're writing a web application, you'll typically have some sort of entity. Typically, your application will be using some sort of relational database, and an entity oftentimes will correspond to a table in that database. And each row in the table is going to be an instance of that entity. So for example, if we had a customers table that had some columns like ID and name, that would be an entity. And Kubernetes is the same way, but rather than representing these as, customers, orders, things like that, they instead represent infrastructure. So we would have like a deployment resource. And there's a whole lot of stuff that makes deployments actually useful in Kubernetes, but at its core, a deployment is just a blob of data that Kubernetes serves up over plain old REST CRUD concepts, your create, read, update, delete. So in order to do this today, we're going to be utilizing the Kubernetes Extensions API to tell the cluster about the shape of our data. So here, in the documentation, we're going to be using what's called custom resource definitions to do this. So custom resource definitions are themselves a resource in Kubernetes, and what they do is they tell the API server how to serve up custom data. So we have all the built-in things like deployment services and all those things I mentioned earlier. Custom resource definitions allow us to add what we want into there. So for example, if we wanted to add a customer, we could do that using a custom resource definition. So all this talk is boring. Let's get into some actual code. Let's start doing some things here. So to start out, I've got a simple Go application over here that is just serving up some customers. It's nothing fancy, it's 25 lines, not doing a whole lot. I'll talk through it pretty briefly. So at the top here, we've got our customer struct, and it's very simple. All it does is it has a name. And then we just have, a customers variable that has a single customer in it over here. And then if we go down a little bit further, we've got our endpoint. We've got a customers function here. It's following the Go HTTP library conventions. All we're doing is we're just creating a new JSON encoder that's going to write to the HTTP output, and we're encoding that customers array in here. And if it fails for some reason, then we'll just write out an error. And finally, in our main function, we're just going to listen and serve on port 8080, and we'll give it our handler function for customers. So if we head back over to the terminal here and get this going, we'll do go run, and we'll give it API main.go. And there we go, it's paused, so we know that it's running. And then let's get another terminal here. And let's just do a simple little curl request. You can see in my shell history I was practicing this earlier, but we'll give it localhost 8080, and boom, there we go. There's our Joe Schmo customer returned to us in a very small JSON package. Yeah, we're going to do this pretty much exact same thing, but instead of using Go or any other conventional web framework, we're going to do it using purely Kubernetes stuff. And spoiler alert, we actually don't have to write any backend code to make this work, unless you consider YAML backend code. We have to write a YAML file. But no actual backend code. And in fact, even the client libraries are already implemented for us. We have to write very little code to make this work, which is kind of cool. So let's close out of this stuff, and actually I just closed the terminal. Let's get that back open. Obviously, if we're going to be doing anything Kubernetes, we need a cluster first. So let's use kind, and let's just spin up a quick cluster here. If you're new to Kubernetes and you're wondering like, hey, isn't that some of that complexity that you were talking about? Typically, this is something that your cluster administrator would be handling. They would be handling the cluster provisioning, configuration, control plane, and this is going to pop up with like a CNI and a storage class and stuff. It's not something that a typical application developer would have to worry about. And once this is done, we'll just jump right into using this as a silly little REST API. So we've got our cluster, and we can interact with it using the kubectl command line utility. And on my machine, I've got this alias 2K. I type that often out of muscle memory, so if you see me typing K and you're like, what the heck is that? It's just an alias for kubectl, kubectl, whatever your preferred pronunciation is. So yeah, we've got our cluster, and believe it or not, we've already implemented the database, the API, and even a lot of the front-end client as well. But what we do need to tell Kubernetes about is our customer entity. So let's create a YAML file. Let's call it customer.yaml, and inside of here, we'll write our custom resource definition to tell the cluster about the shape of our customer. Tell the cluster about the shape of our customer. I think I said that right. Anyways, so let's head back over to the docs. I don't memorize this stuff. You shouldn't have to either. If we scroll down a little bit further here on the custom resource definition page, they've got an example for us to pull from. So with, I think, almost every Kubernetes resource, we have to have a kind and an API version. The API version has two parts. It has the group here at the beginning and then the version. This will kind of come back up in a minute when we're actually defining our customer. But for now, let's just copy paste this stuff to kind of get things going here. And even let's take the metadata too, because we'll be writing that out in a second. So go over here, we got our API version, and this is that extensions API I was talking about. So this is the group for the extensions API. This is something that's built in, and it is stable, so we do have a V1 version of it. And the kind is the custom resource definition. So there's a little bit of meta stuff going on here. Hopefully it's not too terribly confusing. But what we have to do first is we have to tell it what the name of our data is. So it's going to be something customers, whatever. And if we go back to the docs, they'll tell us what that shape is supposed to be. So most names don't have too many restrictions on them. There's this whole DNS label thing. But beyond that, you can name them whatever you want. Custom resource definitions have to follow a little bit of a structure. We have to give it the plural form of our data, and then we have to give it a group. And that group can be whatever we want. And the plural form can be whatever we want. But it does have to be in that plural.group form. So for us, we're going to have customers. That'll be our plural. And we'll just say .example.com as our group, because it doesn't really matter. We don't have to own this domain, and example.com is great for just random stuff. So after we've got some of that boilerplate set up, we'll start actually writing the spec. So the spec is short for specification, and that's just how Kubernetes is actually going to do stuff. So we've got a little bit of redundancy. We have to define the group explicitly. It's not going to parse that out of the name. So we'll tell it that our group here is going to be example.com. And if we go back, we'll see that the next thing we got is the versions. So, if you've ever written a REST API, I hope that you've touched on versioning your API in some capacity. Definitely version your APIs. There are very good reasons to do that. And at Kubernetes, those are front and center. So the very first thing we do before even defining the shape is we tell it the versions. And I didn't actually copy that, but we can just type it out manually. So this is going to be an array. And the first thing that we do is we give the name of our version. So we'll just stick with v1 because it's short and simple. Up next, we have to tell it a little bit about how this API is supposed to work. So we have to tell it to serve the API. Otherwise, Kubernetes will just pretend that this doesn't exist. So we'll say served true. And another thing is that in order to manage these versions properly, we can only store a single version. So when it's persisting data into the database, it can only use a single version. And there's conversion and stuff. Luckily for us, we only have a single version. So we'll just set storage to true and call it a day. Next up, we have the actual schema for our customer. So this is where we'll really start getting into our domain-specific stuff. So we have schema, and then specifically we have OpenAPI v3 schema. So in case you haven't heard of OpenAPI before, it's amazing and awesome, and it allows you to describe your APIs in a language-agnostic fashion. And there's a whole ton of code generation and stuff built around this too, but I won't go into that here. For now, we just need to start typing out our schema. And we'll have OpenAPI v3 schema. Let's make sure I capitalized all those things properly. OpenAPI v3 schema, yeah. And this is sort of a requirement. The very root has to be an object of some kind. So we'll say type object, and then we can start defining the properties of our object. So to kind of stay consistent with Kubernetes conventions, like I said earlier, most resources are going to have a specification at the top level, so we'll do that here. We'll have a property that is called spec, and this will also be of type object. And then to kind of match our Go API from earlier, we will give this a property of name. So we'll say properties, name, and this will be of type string. There we go. And we're pretty close to done. Just a couple more things to do here. All resources in Kubernetes have a scope, so they can be cluster scoped or they can be namespace scoped. So namespaces are just another concept for grouping things together. We don't need to worry about it too much. For this demo, we'll just do a namespace scoped object. Kind of keeps things simple. And then we got to give it the names. So Kubernetes isn't going to try to do anything fancy and interpret the names for you. We got to tell Kubernetes what the names are explicitly. And we'll give it the plural form, the singular form, and then we will write out what our kind. This is typically going to be camel cased, and this is what you'll see most often. Looking at custom resource definitions, what we see up here. So let's go and we'll do our names and we will give it the plural. Same thing that we described up above. This is going to be customers, and then singular is going to be customer. And finally, we have the kind, which we'll just capitalize the C and call it customer. Now, hopefully I did everything right here. We got our indentation all matching and all that. Let's apply this to the cluster and see if it's working. So if we do kapply-f and we'll give it customer.yaml, sweet, we can see that it is created just fine in the cluster. And if we now do, and we fetch the custom resource definitions, we can use kube control get CRDs to do this. It'll list out, hey, look at that. There is our customer's custom resource definition that we just created. And kind of a little bit spoiler, this like kget, we also have like kdelete and patch and so on. These are actually just doing the same CRUD, create, read, update, delete operations that you would do with something like curl, like we did earlier to, get the customers from localhost 8080. All right, so now that we've got our cluster running, we're effectively done with the backend. We've got the API, we've got the database. We even actually have client libraries already written to consume this stuff. So let's run with it. Let's start writing some code for our little pseudo client here to consume the customer entity that we now have in our Kubernetes API. So I've got just a very basic package JSON set up here, npm init and all that. Let's cd into our client directory, and let's create an index.ts file to start writing some code in. We need to install the Kubernetes client node package, so we'll do npm install. We can do @kubernetes client node. It's got to do the npm thing, create a black void of files in here. Yikes. Luckily, let's just look at the index.ts file here. So to make things a little bit more convenient, we'll import everything as K8s, and we'll say from Kubernetes client node. There we go. And the first thing that we'll need to do is we'll need to tell the JavaScript about our kubeconfig. So our kubeconfig contains the authentication details for connecting to our cluster. It's got certificate info and all that fun stuff. So we actually get authentication out of the box as well. One of the cool things about this, but still don't do this in production. This is a terrible idea. To see the kubeconfig, we can use kind. We can just say kind get kubeconfig here, and it'll print out everything. This is my certificate data. Feel free to copy this if you want. This cluster is going to get deleted as soon as I'm done recording. But yeah, this is all that we need to authenticate to our kind cluster running on the machine. So to do this in JavaScript, we'll need to create a kubeconfig. We can call it KC, and we'll do new k8s.kubeconfig. And this class has some methods that will make it easier to load up this configuration. So we can do load from default, can load from a number of sources. Default's going to work for us. And then we can actually start making calls. So like I mentioned earlier, we're using the custom resource definitions, or the extensions API. So we need an API client that knows how to talk to that. So we can create a const API here, and we'll give it kc.makeAPI-client. And this library has a kind of interesting way to do it. We actually passed a client constructor here to tell it what methods are available and stuff like that. So we can do k8s.customObjectsAPI. And now we have a client that is all set and ready to go to do some of this stuff for us. So let's create a customer. This will be a call, so we'll call our variable here res, or response, and we can do api.create namespace custom object. So if you remember earlier, we had scope set to namespace for our customer, so we'll reuse that here, and this does return a promise, so we'll make sure to await it. Top level await, fun thing. Love modern JavaScript, isn't it amazing? TypeScript in this case. And inside here, we've got a number of parameters we got to provide. So we'll start out with the group. So as we mentioned earlier, this is going to be example.com. And then we also have the version, which we set to be v1. We also have the namespace. Let's just create this in the default namespace. And the plural is going to be customers. And let's organize that a little bit different. And finally, we need to give it the body. So we have a little bit of duplication here. This isn't exactly, the correct way to be doing these sorts of things. So we have a little bit of duplication. Shouldn't be too bad at the end of the day, but we do have to duplicate the API version. The body is basically going to look like that YAML file, or very similar at least. So in the API version, we have our group version, and then we have kind. And kind is going to be customer. And then as we did, first we got to have some metadata. So in here, all we got to do is give it a name. The namespace will default to default. So name has to be lowercase because this has to be a DNS label, but luckily, let's put a A there. Luckily, on our spec, we can give it a name which is a little bit more freeform. So spec, we have our name, and let's just capitalize the T. We'll call it test. Actually, you know what? Joe Schmo was in our Go example, so let's call this Joe Schmo. And finally, let's print out what it gives us back. So not const, console.log. And to make it a little bit more readable, let's JSON stringify the response, and then let's pretty print it with 2 spaces. So now, if we run this, hopefully, if I did everything correctly here, we should see that a customer object is going to get created in our cluster and returned back to us, and hopefully printed out on the console. So if we execute this file, we'll do node index.ts, and in order to run TypeScript files, we're going to use the fancy new experimental strip types. Believe it or not, Node can execute JavaScript files. I did that in the wrong order. Node experimental strip types. There we go. And I set up the package JSON incorrectly. So let's fix this. Common.js, we'll switch that to module. Main, I don't know if that even matters, but let's just, boop, there we go. So look at that. A little bit of a hiccup, but we got there. And let's make this full screen. So yeah, this didn't do a whole heck of a lot. Basically, it just created a customer in the cluster and returned it back to us. So you can tell that the Kubernetes cluster did something because we have this weird manage fields thing. We've got like a creation timestamp. We've got a generation. One of the cool things is that we get IDs out of the box. Kubernetes resources have UIDs or universal IDs that are just GUIDs. So we've already got an ID for our resource. And then you can see the data that we gave it down here. We've got a spec. So like I mentioned, kubectl can perform these REST operations for us. So it would stand to reason that we could do get customers, and we should be able to see our customer in here. And look at that, we got it. The get customers returns our test customer. And the kubectl will even let us format the output. So we can say -o YAML, and we can get this as YAML. And we have the list resource, which has items, and then inside items, we have our customer. And we can do this as JSON to be a little bit more similar to other standard JSON REST API stuff. And there we go. All right, so with that, we have completely abused Kubernetes to write a plain old REST API, and we didn't have to write any backend code. We got authentication, we got a database, we've got a cluster. If we want to make this highly available, we could even do that. That wouldn't be too difficult. It's pretty crazy. Obviously, don't do this in production, though, and there's a pretty good reason for that. And let's go talk about the architecture real quick, just to see what's really going on here. So I've got just simple draw.io stood up here, and I just kind of lined out sort of your basic API structure. You'll have a database, you'll have an API, and you'll have some sort of client that's connecting to it. Given my background is very .NET, Microsoft stack kind of stuff, I've just kind of put the comparison for that stack. You'll probably be using SQL Server, probably be using ASP.NET, and you'll have some sort of web browser client. This could be a React app, an Angular app, maybe Svelte if that's your thing. So let's take this same thing and let's see, like, what exactly did we do here now that we're using Kubernetes? So believe it or not, this picture actually doesn't change all that much. We really just have the names of things changing. So when we're doing this in a Kubernetes cluster, the database is etcd. I don't know if that's capitalized, lowercase, whatever, etcd. And this is just a basic key value store. The API here is the API server component of Kubernetes. And the client is just any Kubernetes compatible client. So it still could be a web browser. This code does execute in web browsers. Well, okay, big asterisk there, but it can. In our case, we used kubectl, and we also used the client node library. So the picture is really pretty similar. Of course, there's so much complexity in Kubernetes, and I'm kind of glossing over here. But I think when we're trying to learn it, it's good to point out that some of the fundamentals aren't all that different from the same things that we're used to working with in our jobs. Now, you may be thinking, like, so we did all that, but like in my APIs, I write validation for my code. I don't let clients just do whatever they want with my entities. Believe it or not, Kubernetes also has something out of the box for that. If we go back to the docs and we go to the index over here, there is a section about validation. So as it happens, we can encode validation into that same YAML file, and Kubernetes will do validation of these entities when we're creating them. So that's another thing that we just get out of the box. Now, you may be saying next, like, okay, hey, my API does a lot more than CRUD. I've got, other services that I connect to, other things that I do. Maybe I'm publishing events or something like that. And that's where you got me. Yeah, this is a terrible idea to do in production. We're totally misusing Kubernetes here. Your API probably will do a lot more, and this is probably not going to be the way you want to do it. If you're interested in seeing how Kubernetes could help you in that area, that's where controllers come in. I won't touch on them in this video, but further reading, go check out controllers. It kind of stems from robotics and automation. Again, I'll call out my coworker Ben Pratt's talk. He covers this sort of stuff. Really cool things. But yeah, completely misusing Kubernetes to demonstrate that it really is just a CRUD REST API. This has been Eric with Technically Speaking at Source Allies. Do you have a topic that you want to see covered? Comment it down below. And check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.